and in this session we are going to learn about the two protocols and the application of real-time interactive audio and video. So the first protocol is RTP, which is also known as real-time transport protocol. So it is a protocol designed to handle real-time traffic on the internet, i.e. audio and video. But RTP does not have a delivery mechanism, like it doesn't support multicasting, it does not have any port numbers and so on. So it must be used with UDP. So RTP is just like a sandwich. It is sandwiched in between the UDP and the application layer. So what are the applications of RTP? So basically RTP helps in media mixing, sequencing and timestamping. And voice over internet protocol is a really big application of RTP, and we are going to study in further on voice over protocol. And then we have video teleconferencing over the internet and internet audio and video streaming. But how does a RTP packet looks like? So this is the packet format of RTP. We have various fields here like VER, P, X, payload type, sequence number, timestamping and many more. And let's discuss them. So VER is the version number and it is a 2-bit field and it defines the version of the RTP packet. And currently it is running on version 2. And then P, it is a 1-bit field and it indicates the presence of padding at the end of the packet. And then we have sequence number, and it is a 16-bit field and it is used to name the RTP packets. And then we have the next protocol, which is RTCP. But the question should arise here that why do we even need RTCP? So RTP only allowed one type of message, the one that carried data from source to the destination. But in many cases where there is a need for another messages in a session, what do we do then? So hence comes in RTCP, which is also known as real-time transport control protocol. And here is the flow structure of RTP and RTCP. So this is a sender. This is sending any data over the internet to the receiver. But how do we know that the receiver has acknowledged or received the data? Because we are running UDP, so we do not know that because it doesn't have any error controlling mechanisms. Hence we have RTCP. So the messages that can control the transmission and quality of the data, as well as also allow the recipients so that they can send feedback to the source, that is known as RTCP. And RTCP has 5 types of messages. Let's discuss them all. So the first message is the sender report. So it is sent periodically by the active senders in a conference to report transmission and reception stats for all the RTP packets. And it has, like, the sender report includes an absolute timestamp, and the absolute timestamp allows the receiver to synchronize different RTP packages. And then we have the receiver report, like the passive participants, those who are not contributing in the RTP packet sending. So this report is used to inform the senders and the other receivers about the quality of service. Then we have SDM. So the SDM is like to give any additional information about itself. The information can be name, email address, telephone number and the address of the owner. And then we have the bye message. So the bye message is just like, okay, yeah, bye, we are shutting down the stream and we are leaving the conference. And then at last we have application specific message, and it can be used to extend the type of application. And now we have read about both the protocols, and now it's time for the application, which is voice over IP. So the idea here is to use the internet as a telephone network with some additional capabilities. So can you imagine using the internet as a telephone network? So instead of communicating over a circuit switched network, the application allows communication between two parties over the packet switched internet. But how does it work? So our voice is converted into a digital signal by VoIP services, and then it gets compressed and sent over the internet. Then a voice VoIP service provider sets up the call between all the participants, the receiver and the sender, and on the receiving end, the digital data is then uncompressed into sound that we hear through our headset or the speaker. So let me go through it again. Let's use white. So our voice is converted into a digital signal and then compressed and then sent over the internet. Then a VoIP service provider sets up the call between all parties, receiver and the sender. And after that, on the receiver end, the digital signal is again decompressed into the sound that we hear through the phone or the speaker. Now, what are the advantages of VoIP? So first of all, it's low cost, right? Then portability, we can put it in our phones, in our pants, and then no extra cables. Thank God, no extra cables. And video conferencing. I told you at the start that we are going to discuss about video conferencing. This is the application on which video conferencing is based. Then we have two protocols which have been designed to handle this type of communication, the voice over IP. So first one is SIP and the second is H.323. So SIP, the session initiation protocol, is an application layer protocol that establishes, manages and terminates a multimedia session or a call. And SIP is designed to be independent of, like, it can run on UDP, TCP or any other protocol. And like in a regular telecommunication, how do we identify that who is calling? So we have the phone numbers, right? So through the phone number we can identify that who is calling us. And here in SIP we have a similar thing, which is the SIP email address or the SIP IP address or the SIP phone number. And then we come to the second one, which is H.323. So basically H.323 allows telephones on the general public telephone network to speak to the computers connected to the internet. Let me repeat again. So H.323 allows telephones to communicate directly to the computers connected to the internet. And here is the architecture of H.323. Let's see it clearly. So this is the telephone network connected to a gateway and then an internet which is connected to the computers. So at the center there is a gateway placed which connects the internet to the telephone network. Gateway translates a message from one protocol to another and it speaks H.2.3 protocol on internet side and PSTN, i.e. public switch telephone network protocol, on the telephone side, and it acts as both the computer and the telephone. So here we are communicating through this gateway between the internet or the computers and the telephone network. So this is how voice over IP works, and that's it for today. In the next videos, we'll go through the quality of services and how to improve them. Thank you.